Alright, so we are working on solving rational equations, part 2. And so we're just going to talk about some harder problems, also talk about a couple of questions that I got on the homework quite a bit. So I wanted to go through them and kind of see how everybody's doing with them, and that's number 3 and 5. By the way, if you have any questions on 1, 2, or 4, and you want me to go through them specifically, please let me know. I'd be happy to do that for you and see how everybody's doing on that. On number 3, we've got 10 over 2x plus 1 plus 4 over 3 equals 2, and kind of just to keep us in this mind frame of that we're going to have eventually a test over all rational expressions, rational equations, we see an equal sign. And as soon as we see an equal sign, that should tell us in our head we need to find the LCD, and then we need to multiply every term by the entire LCD. The first thing that can be kind of difficult for kids is that we just see a 2 over here. Well, remember, any number can always be written over 1. So my denominator there is really just 1. Now we need to find our LCD. Remember that 2x plus 1, if you see in a denominator or numerator for that fact, if you see a plus or minus in the denominator, that is a quantity. So 2x plus 1 is a quantity that needs to stay together. That has to be included, the entire thing, part of my LCD. Then with regards to just numbers, I've got 3 and 1. Well, 3 and 1, what number do both those go into? That would simply be 3. So now I have my LCD, and I'm going to multiply, since there's an equal sign, every term by that LCD. So I've got 3, parentheses, 2x plus 1, times my first term of 10, 2x plus 1, plus 4 over 3 times my LCD of 3, 2x plus 1, equals 2 over 1 times my LCD of 3, 2x plus 1. So now that we've multiplied, now we can go ahead and cancel what we see. So again, right over here, this left spot, in my denominator I have a 2x plus 1, in my numerator I have a 2x plus 1, which just leaves me 3 times 10. Over here I have a 3 in the numerator, 3 in the denominator, which is just going to leave me 4 times 2x plus 1, equals, I don't have anything in the denominator that would cancel with anything up top. So I have 2 times 3 is 6 times 2x plus 1. So now I get to this step. At this step, if you did it correctly, you should not have any denominators left. If you have a denominator left, it means you made a mistake. Your LCD might be incorrect, you might not have canceled everything you can, but you should always cancel out your denominators. So I can go ahead and simplify. And then combine like terms, so 30 plus 4 is 34, plus 8x equals 12x plus 6. At this point, get all of your x's on the same side, all of your constants on the same side, and you get x equals 7. And you can go ahead and check it by plugging it back into this spot right here and making sure your left side equals your right side. I've had a couple kids ask me, are you going to require us to check? Well, you kind of know how I like to work. I prefer you to check. If you have the possibility to see if you got the right answer before you turn something in, why not? Doesn't make any sense to not do that. But I understand with me giving shorter periods for quizzes / tests, if you don't have time, I understand you. I'm not going to require you to check it. But if you have time, perfect. Plug in the 7 and see if you get the right answer. Alright, so now moving on down here. I have denominators of x minus 5, x minus 4, and x squared minus 9x plus 20. And again, I see an equal sign, so I know I need to find my LCD. And then I need to multiply every term by that LCD. Notice the difference here. Yes, up top on number 3, I have a 2x plus 1 in my denominator. I cannot factor any further, so I don't need to factor my denominators. And the reason why I know I don't need to factor it is because my x in this 2x plus 1 does not have an exponent on it. Down here, I see a squared on my x. That's giving you a hint, hey, you can probably factor that. You need to factor this before you go ahead and find your LCD. So my LCD on number 5 is not x minus 5, x minus 4, x squared minus 9x plus 20. We need to factor this first. So I can't pull anything out, so I draw my two parentheses. I know my first two spots, my first spot in each parentheses, has to multiply to x squared. So that's got to be x and x. My back sign is a plus, so I look to the front and I have two of those, so I have a minus and a minus. And then my back two spots have to multiply to 20 and add to -9. Well, that would be 4 and 5. And what do you know? My factored form is the exact same as my first two fractions. So my LCD here is x minus 5, x minus 4. And so I'm going to multiply every term in this problem by x minus 5, x minus 4, times 8 over x minus 5, minus 9 over x minus 4, times x minus 5, x minus 4, equals 5 over x minus 4, x minus 5, times x minus 4, x minus 5. Alright, so now I got my whole problem written out. Let's cancel what we can. In my first one, I got an x minus 5 down here with x minus 5, leaving me 8 times x minus 4. Over here I have minus 9. My x minus 4's cancel out, so I'm left with just x minus 5. Equals x minus 4 cancel out, x minus 5 cancel out, just giving me 5. And so now, again, at this step, no denominators. Make sure you remember that. Okay, you will always have no denominators at this stage. So I can distribute. Remember, we're distributing this as a -9, so -9 times -5 is positive 45. Combine like terms. Subtract the 13 over. And I am not done because x is not by itself, so I divide by -1 to get x equals 8. And again, at this point, I would expect you to go ahead and, wouldn't expect, but would love for you to plug that back in and check to make sure that it works. So you have to plug that x equals 8 into this x, this x, this x, and sorry, that is not an x. This is an x, though, right there to check it. All right? So those are the two from the homework that I wanted to go through. Again, if you have any questions about 1, 2, or 4, though, please send me an email. I'd be happy to send it through. All right? Moving on, I want to go through a few more examples here. So again, on this one, it's very similar to the last one. Go ahead and pause the video if you have time and try to work through this by yourself. On this one, because I see a squared here, again, that's like the first trigger in my head, hey, you're going to need to factor this. Also, there is no number in common, and I have a 2 out in front. So my factoring is going to be a little bit more difficult. Instead of x and x, I know it's got to be 2x and x. I got a minus sign in the back, a plus in the front, so I know I need to have one of each. And since there's a number in front of my x squared, all I know is that these back two terms have to multiply to 4. So I'm going to put a 1 here and a 4 there. We need to check our O and our I. So when I look for my outside, that's part of the foil. 2x and 4 is 8x. -1 and x is -1x. Those add up to positive 7x. So I know my factoring is good. Just like before, what do you know? Let's see if I can match these up. 2x minus 1, 2x minus 1, x plus 4, x plus 4. Now, is it always going to be like that? No. But a lot of times your first two fractions will give you a picture of what it's going to be like. So use that, all right? Again, not a guarantee, but that can often happen. So now I need to find my LCD, which is 2x minus 1. Again, Minus sign in between means that this is a quantity. X plus 4. Plus sign in between, so that's a quantity. And that covers my last fraction. 2x minus 1 is covered, x plus 4 is covered. So now I multiply everything out here. Times my first term of x over 2x minus 1 plus 3 over x plus 4 times x plus 4 2x minus 1 equals 21 over 2x minus 1 x plus 4 2x minus 1 x plus 4. Some logistical issues out of the way here, sorry. Alright, so now, got that all multiplied out, let's go ahead and see what we can cancel. So, over here, I get a question a lot of time on this fraction right here. Can I cancel my x's? I got an x up top and an x connected to the 2. Well, remember, there are 3 terms in this fraction, x, 2x, and then negative 1, because the minus sign breaks up those. It would have to be in common in all 3 to be able to cancel my x's, so I cannot cancel an x there. So I can cancel my 2x minus 1s, cancel my x plus 4s, and again, both my denominators cancel over here. And so I'm left with x times x plus 4 plus 3 times 2x minus 1 equals everything canceled out over there but 21. So I can distribute 3 times 2x is 6x minus 3 equals 21. And we can combine our like terms, so 4x and 6x gives me 10x minus 3 equals 21. We cannot combine the x squared and the 10x because they're not like terms. Subtract the 21 over, and I get x squared plus 10x minus 24 equals 0. And let's talk about this previous step. I'm here. Why do I know I need to subtract the 21 over? Well, hopefully you're all thinking or remembering I have a squared on my x. Hopefully you also understand this is the first time with solving rational equations we've seen a squared on my x at this point. This is a quadratic equation because we know anytime you have x squared, it's going to be quadratic. We know how to solve quadratic equations a few ways. We've worked on this year, and it's going to be very important for you going on to Algebra 3 or College Algebra next year to remember that. You've got an equation, you have an x squared. We can either solve it by the quadratic formula, which it's okay. You can do it. I think it takes a little bit longer. We could do completing the square, which you're not going to want to do. I don't believe so. At least it's one of the rarer things people use. And the other main one we've got is solving by factoring. So we know with solving by factoring, before you can factor, you have to get it equal to 0. So that's why I subtract my 21 over. Now I can factor this, by getting my 2 parentheses, x and x. I've got a minus sign in the back, so it means I'm going to have 1 of each. I need to multiply to negative 24, add to positive 10. The only way I do that is x plus 12 and x minus 2. So I've got it factored. To solve by factoring, I need to set each of these parentheses, x plus 12 equals 0, x minus 2 equals 0. Subtract the 12 over, add the 2 over, and I get x equals negative 12 and 2. Got two possible answers, okay? It's not a guarantee that all of them are going to work, okay? If one of them would not work, I would put in the question, make sure to check your answer. And if I put on the question, make sure to check your answer, make sure you do so. I'm doing that on purpose, all right? So in this case, let me check them real quick here because this is live practice. Well, 2 works when I check it, so we're good there. And negative 12. 12 over 25 over negative 8 equals 21 over 400. So, and so both of them do work. If you have a question on how I got some of that, go ahead and get your common denominators and so forth. But both of them work, so both answers would technically work there. All right, so I've got 3 more here. I'm only going to go through 2, and then I'll post the work for the third answer in Google Classroom. And so let's go ahead and skip this one because it's going to be very similar to the previous one. Let's go down here where I've got y plus 2 minus y over 2 minus y, and then y squared plus 4 over y squared minus 4. So again, I see an equal sign. I know I got to find the LCD and multiply every term by that. I also see a squared in the exponent, which means I need to factor this. Hopefully we also have the difference of square of y plus 2, y minus 2. Again, just to make sure we're all on the same page here, I cannot cancel the y squareds and the 4s. They are not the exact same thing, so I cannot do that, okay? There are 4 terms in this fraction. It would have to be in common in all 4 terms to be able to cancel it. Now, this is a little bit different than the previous ones. Yes, my y plus 2's match up, but y minus 2 is completely different than 2 minus y. So what I'm going to do here to make these be the same, I'm going to pull out a negative, which makes this negative 2 plus y. Notice, negative 2, positive y, positive y. These are the same. So now I have my LCD. I've got y plus 2 from my first fraction. I've got y minus 2 from my second one, but I also have this negative that needs to come out front. So there's my LCD. So I need to multiply every term by that. So go ahead and do that. Pause the video and solve it. Alright, you are back now, and we're going to get rolling here. Alright, so we can go through and cancel some items here. Y plus 2, y plus 2, y minus 2, y minus 2, negative, negative, y plus 2, y plus 2, y minus 2, y minus 2. And I forgot my negative over there for my LCD. So, coming back here, got my negative out front, so negative times 2 is negative 2 times y minus 2 minus y times y plus 2 equals y squared plus 4 times my negative of my LCD. So I can go ahead and distribute here. Negative 2y plus 4 minus y squared minus 2y equals negative y squared minus 4 when I distribute this negative to both terms. So I see a squared term. The first thing I want to do, you can combine like terms, but what I'm going to do is I'm going to get everything over to one side. So I'm going to add y squared over, I'm going to add 4 over, and I'm going to be left with negative 4y plus 8 equals 0. Notice that my y squareds cancel out. So I thought this might be a factoring problem, but it's not, because all I have left is a y. So I'm looking to solve for y here. I would subtract my 8 over, divide by negative 4, and I get an answer of y equals 2. Again, you got time, check it. That would be wonderful. If not, if it comes out as a solid number, as in 2, negative 5, 8, 12, you probably did it correctly. But again, there's no guarantee there. The only way you can guarantee it is if you check and get the right answer. Alright, the last one I want to work on is this. 3x minus 2 over 9x plus 1 equals 2x minus 5 over 6x minus 5. Alright, so let's talk about how we've been doing this. Well, we're solving rational equations, and technically, yes, even though we don't have a plus or minus in between fractions anywhere, we're solving rational equations because I have an equal sign. So I would find my LCD. Both of my denominators, there are no exponents on my x's, so my LCD here would be 9x plus 1, 6x minus 5. We've got our LCD, we would multiply each term by it, something like this. Alright, so we can do that again, cancel my 9x plus 1, cancel my 6x minus 5, and I'm left with this. Before I go further there, let's talk about something that you've learned before. You learned probably back in 8th grade, maybe freshman year. We have a fraction equals a fraction. Remember, we learned that you could cross multiply and solve. So I would have 3x minus 2 multiplying with the bottom right of 6x minus 5 equals 9x plus 1 times 2x minus 5. Alright, let's look at my two problems. What do I have left in my rational equation problem? This. What do I have left in my cross multiply problem? This. Hopefully we get the exact same expression, showing either one works. It's completely up to you which one works better for you. So go ahead and solving. Over here I got a parentheses touching a parentheses. What does that tell you to do? Yes, we need to FOIL here, so I'm going to FOIL it and get 18x squared minus 15x minus 12x plus 10. Again, first, outside, inside, last, equals 18x squared minus 45x plus 2x minus 5. Again, first, outside, inside, last. So I can go ahead and either combine like terms or get everything equal to 0, whichever one you want to do first. I'm going to get everything equal to 0 by subtracting the 18x squared over. adding 45x over, subtracting 2x over, and adding 5 over. When I look at this, 18x minus 18x squared cancels out. Negative 15x, negative 12x is negative 27x. When I add 45x, I get 18x minus 2 is 16x plus 15 equals 0 because everything cancels out over here. And subtract the 15 over, I get 16x equals negative 15. Divide by 16 and I get x equals negative 15 over 16. So this would be a case where you get an answer that I would be a little bit concerned on because, like I said, most time you should get whole numbers. So let me kind of look through my work here and make sure I didn't make any mistakes. The math looks good to me, so if you find an error down the road, you let me know. But this is kind of showing a little bit more of a complicated rational equations. Reminder what you are going to be working on. One, I've posted a schedule for the rest of the semester in Google Classroom underneath the weekly schedule. And I should have sent you an email this morning that you would have received showing what the schedule is going to look like, so that way you can be familiar with it. Today, what you need to do is you need to start and finish a worksheet over solving rational equations, some of these harder problems, so that way you're going to be ready for the quiz that will be on Tuesday or Thursday, depending on what class you're in. Remember, next class, we're going to have a Zoom session quiz. That quiz is going to be 20 minutes after the hour. I'm going to send out directions on it, but you'll need to have a phone handy that has Zoom already uploaded on it. You'll also need to have your iPad ready because you're going to be using your phone as a Zoom session to aim it at your iPad, have it set up so that way I can see and make sure that your iPads, you're not going anywhere else. You're not using Photomath, you're not doing anything like that. All right. If you have any questions on that, please let me know. Pretty much every other math class is doing it, so it's not like I'm doing anything crazy here. After the quiz on Tuesday/Thursday, we will have a review for the test over solving rational expressions, rational equations, and the class after that will be your test over all rational expressions and equations. If you have any questions, please let me know. Have a great weekend and a great day.